Welcome back, everybody. So hopefully the microphone should work. Yeah, all right. So before I continue, I'll take the time for answering the questions in the chat and also saying a few words about how to make the exercise notebooks work. So let me maybe start with the notebook. So some of you came in the break asking questions about that. So I think it's worth telling everybody. So the way that this works is that if you try to install locally PostgreSQL yourself and Jupyter Lab and so on, it's cumbersome. You have to configure a lot of things. It depends if it's Windows, if it's Mac, if it's Linux and so on. So it's very complicated. We used to do it like this. But now what we have is a better solution that is using a technology called Docker. Docker is basically a technology that allows us to package the whole PostgreSQL database and Jupyter in some black box that you just download and that just works on your machine. So what that means is that you should not try to directly run Jupyter Lab or Jupyter Notebook on your side or to configure anything like that, because then you're going to get errors that SQL is not recognized and so on and so on. Instead, what you need to do is go to the Moodle of the course, look for the exam magic box, download it, it's a zip file, and you unzip it. That will create a directory called exam docker. You need to go to that directory and type a command that's called docker-compose --up. In order for that command to work, you need to download Docker, right? It's just an automatic installer that you will find depending on your operating system. But once you have installed Docker, just docker-compose up, it just works. Then you go to your browser, you open it to localhost 8888, and then you will see the list of all the past exam notebooks in there that you can click on, and they should just work. You execute all the cells in there, should just work. Now what happens with the exercises that are distributed to you, you need to download the notebook of the week, so the one, for example, that is given for this exercise week, and you need to put it inside the notebooks folder in your exam Docker. So there's exam Docker, where you run Docker Compose up. There is a subdirectory called notebooks. This is where you need to put all the notebooks that are distributed during the semester. If you put it there, and then you open it via the localhost 8888 with the Docker Compose up command, that should just work. If it doesn't work, then just come to the TAs, to us, ask for support. We can help, but it's really supposed to just work out of the box. All right? So I wanted to say this because I think that some of you manually run Jupyter Lab and then it didn't work. So that was the reason. All right, so that addresses the how to use the Docker. By the way, on exam day, the notebooks that you see in that Docker, they are very similar to what you see on exam day, right? It's not going to be Docker, but you'll still have a browser with Jupyter notebooks and so on. And so that already gives you a pretty good impression of what you'll have on exam day to run your queries. Now, two questions on Zoom. So perhaps you can read the first one, Xiaocheng.
Yeah, so the first question is MapReduce just a count grouping method? If yes, why is it so secretive?
So the first thing I will ask is who heard of MapReduce? Who never heard of MapReduce? Okay, MapReduce is not part of the course material. This is something we do in Big Data for Engineers. If you visited Big Data for Engineers, then you will, of course, already have heard of MapReduce. MapReduce was invented by Google something like 20 years ago. MapReduce should not be seen as a database or as SQL or something like that. Rather, it should be seen as a very, very clever implementation that is able to massively aggregate data. And here I mean petabytes of data, like huge amounts of data, not on your laptop, of course, because you cannot have petabytes of data, but in the clouds. You have a cluster of machines, you have 1,000 machines, and you have petabytes of data spread all over the machines. MapReduce is basically capable of going to all of this data in parallel in all the machines and of basically computing group bys. in a way, right? That's one interpretation of MapReduce. So what I showed you with the group by earlier, it was just very little data on a screen. But if it had been billions or trillions of records that you want to group by in this way, then you would typically use something like MapReduce, right? It's really a physical implementation that is able to do group bys on trillions of records. So there is indeed a link. It is indeed related to group bys. But the thing is, MapReduce is more powerful than that. It cannot just do group by, it can do many, many other things. You can also use MapReduce for selection, MapReduce for projection, and so on. And in fact, there's also more modern technologies than MapReduce. There's, for example, Apache Spark, which is also something we see in big data for engineers. The way to understand it is in terms of data independence. MapReduce, Apache Spark, and so on, it should be hidden from you. That should be something that is somewhere running in your data center, but you as the end user should just write SQL. If you write SQL on your laptop, it's going to be run by PostgreSQL. If you write SQL using, for example, BigQuery of Google, and you write SQL there, then it's going to run on top of something that looks like MapReduce. But again, you don't even see it. The only thing you see is that the results magically appear in a few seconds or minutes on your screen by magic, even if it's trillions of rows. So MapReduce is a physical implementation of group by and counting. Let's put it that way. Does it answer your question? Yeah. By the way, what did you mean with secretive? That is so secretive. Oh, you just heard it's not public? So let me explain a bit. So it's not part of this lecture, but just for general information. So basically, in the 2000s, 2004, 5, 6, 7, companies like Google, Yahoo, Twitter, many others, they noticed that using PostgreSQL or similar pieces of software didn't work because they had too much data. So it didn't work anymore. So they had to invent their own new technologies, including MapReduce, to make it work. Now, it is true that Google's implementation of MapReduce is not public. They published a paper, though, but the implementation is proprietary to Google. But what happens is that other people at Yahoo designed an open source version of MapReduce. So you can use that one. This one is public, but it's very similar to Google's implementation, right? So this is what it means that it's not public. It's the original one is not public, but there is an open source equivalent called Hadoop. Who heard of Hadoop? Yeah, you did. So Hadoop is just the name of the elephant teddy bear of the kid of dog cutting, who is the inventor of it. So he just named it after this teddy bear. All right. So, yeah, that's the history. If you want to know more, you can go to Big Data for Engineers. This is where we look at taking it to clusters of thousands of machines. Okay. But you don't need to worry. MapReduce is not material for this lecture. You don't need to worry about that. The one material is data independence. That's the idea that you can execute SQL queries looking at tables, and it doesn't matter how it's implemented. Can be on your laptop, can be with MapReduce, can be with DNA. You know, it's all data independence. Okay, and we have a second question.
Yes. So so when we select something from a table named person, and we rename it in the selector clause. So does this rename the queries in the table persons, or does it temporarily create a new table?
It only temporarily creates a new table. So the idea is that when you are sitting on your notebook, let's say on exam day, and you're typing select from where queries, the ones that we're actually learning right now, you don't need to fear anything. It's not modifying the data. Otherwise, it would be a nightmare, right? You're on exam day and then it keeps modifying the underlying data. That would be terrible. So no. This is just on the fly. It's computing something that it puts on your screen, but that doesn't modify the underlying data. It will only modify the underlying data if you start typing commands like delete carry one, delete, update, insert, that would modify the data. Select doesn't modify any data. That's safe, right? You can really write all the selects you want. It's just creating a temporary table that it displays on your screen. Does it make sense? All right. And by the way, if you get it into a mess on exam day and you delete the data or something like that, don't worry, we'll change you to a different computer with a brand new database. I mean, we will have solutions. You still need to be careful though. I mean, this is part of what we'll learn, but if you want to crash the computer, you can. You can basically write some, let's say you have tables with millions of rows and you try to compute the Cartesian product of 3 tables with each 1 million rows. That's basically 10 to the power of 18 records in there. You're going to crash the computer if you do that. So you really need to be aware of what you're doing, right? Do not try to build tables that are absolutely gigantic. You need to understand the sort of queries that you are writing. I mean, even if it crashes, it's not a big deal. As I said, we just move you to another machine and we give you extra time, but still it's creating stress if you do that. Okay. So any other questions? Okay, on Zoom? Okay, so let's move on. Let's just build more and more complicated queries. Selection. Selection is the sigma. Sigma has this subscript with a predicate that says how we want to select the records that we want to have in our output, right? So for example, if you say b smaller or equal to 2, then you get that new table. Okay. How do you do it in SQL? Well, you told us actually earlier because you used the where clause to designate it. So indeed, this is with the where clause. The where clause contains the selection predicate. This is where the sigma subscript goes. So here, if you say select star, meaning all columns, select star from persons, where last name equals crusher, you are basically doing a sigma subscript last name equals crusher. And that's going to output this table right here with a subset of the records, just those that match the predicate. And again, to come back to your question, that's not modifying the original table. It's not deleting the ones that don't match the predicate. No, it's not touching the data. It's just temporarily creating a table that doesn't have a name and putting it on your screen. Okay, so that is a selection in the where clause. Now, what you can put in the where clause, the predicates, you can do a lot of things in there. In fact, you have a whole restaurant menu of things that you can have. I'll come back to that. Yes. So basically, you can do a lot of things. You can compare for equality, like we do. You can compare smaller than. Do I have that? I'm just, yeah, exactly. I'm just shuffling the order of my slides here. But basically, you can compare for equality, for difference. So this, you can use the smaller than, greater than. In some systems, it also accepts exclamation mark equals as a synonym for is difference than. Then you have smaller or equal, greater or equal, strictly smaller, strictly greater. So you can put all of that in your predicate to compare 2 columns. You can also, and here I'm just, you can also combine them with, here. You can combine them with logic, meaning that you can say something has to be equal to something and something else has to be smaller than something else, or something else has to be different than something else. So you can combine them with or, and not. That's the whole first order logic that you have here. Any combination of that. You can use parentheses, of course, if you want to enforce specific precedence in there. But actually, you can build very complex formulas like this, right? So or and not, comparison like this. And you also have arithmetics like plus, minus, division, multiplication, and many others. Okay, but let's get back to the order of my slides because I didn't explain it in the order I wanted. But anyway, so if you look at this query, that's called the query, it's a SQL query. The select from where really is the core of that. There's a name for the individual lines. These are called clauses. So we have a select clause, we have a from clause, and we have a where clause. The select clause implements the projection, as its name doesn't indicate. The from clause reads from a table, specifies which table you're reading from, that would be stored in the system. And the where clause implements sigma, the selection. So these are called clauses. Now, you notice that each clause here is on a different line. And there was a very good question during the break about this. The only reason why they are on different lines is to make it easy to read by humans. That's really the only reason. If you would just put select start from persons where on the same line, it would work too. PostgreSQL is not going to complain. But think of how easy it's going to be for other human beings to read the query that you wrote, right? So this is the reason why we like to put it on separate lines, we indent, and so on and so on. This is just out of courtesy and consideration for your colleagues, basically, and yourself, of course, because you probably also want to understand the query that you are writing. Okay, so these are called clauses. This is a query as a whole. These are clauses, and this is called a predicate. And so predicates can be made of and or not, comparison operations, arithmetics, and so on. So lots of things in there. And these are called expressions. There's a whole bunch of computer science courses just on that, on compilers and how to parse programs made of expressions and so on. And these expressions that you have here, they are really in many languages. You also have the arithmetics, logic, comparison. You have it in Java, in Python, in SQL, in many languages. They just look slightly different. It's like the Swiss dialects, right? So you might have a different syntax in SQL than in Python or in Java, but you just look at the documentation. And by the way, the documentation is available on exam day. You'll have the whole PostgreSQL documentation on your computer. All right, so if you have a doubt on the syntax. So among these expressions, you have, as I said, all the whole first order logic, so and or not. It's really written in English, like OR, AND, NOT, really like this in SQL. In other languages, I don't know if you noticed, but in Java, for example, AND is a double ampersand, OR is a double vertical bar, so you have all these different conventions. But in SQL, it's easy because it's just the English words, so that makes it easier. Okay. Now, I'm just giving you a little bit of a warning about this logic in SQL. Normally in logic, when it's taught, you only have true and false. Then you can do and or not on true and false. That's called the Boolean algebra. But SQL has a third value called unknown that it accepts. And that means that it's able to do this or and this not and this and also an unknown. And this is really here common sense. Basically, imagine that you're playing a game and somebody wrote a formula, something or true, but there is some coffee that was spit over the left part and you don't know what there is in there. And so it's something or true. Well, just with common sense, it doesn't matter if it was true or if it was false or true, right? False or true, true or true, they anyway give you true. So it means that anything or true will give you true. So that means that if you have unknown in there, like you don't know this special value unknown or true gives you true, right? And unknown or false would give you unknown, right? Because unknown or false, you don't know. It could be true or false, then that would be true. It could be false or false, then it would be false. So that's why unknown or false would give you unknown, right? So this is really just a third value, a third truth value that is neither true nor false. It's you don't know if it's true or false. Okay, does that make sense? Very convenient, but that can also give a bit of headache when you deal with all of that. And as you can imagine, this unknown is going to start appearing when you have nulls in there. So if you have a column with a null and you say that column equals to 2, then when it's null, it's going to tell you unknown. It's a null, so I don't know if it's equal to 2 or not, right? So it just says unknown. So this is because of the nulls that you have this third special value, okay? And the same here. If you have anything and false, that's always going to be false. So unknown and false is false. Imagine that this unknown is really just some coffee that was spilled over and you forgot what was in there and you still have to figure it out. Okay. All right. And the same for not. Not true is false, not false is true, and not unknown is unknown. Okay, now there is a way to test for this. If you want to see if something is true or false or unknown, and you really want to distinguish between the three, you have special syntax that says is true, is not true, is false, is not false, is unknown, is not unknown, right? This will always say true or false. It just compares for each one of the three values which one you have, right? So it's very convenient to have this way of specifically asking PostgreSQL, is the result of that formula unknown? Is the result of that formula true? And so on. Okay, for whom is that clear? Right? This is already advanced, by the way. This is maybe not used by many people, but it's still there. Then you have the comparison, as I said, all of this syntax. Again, the one thing that sometimes can be frustrating is the difference sign. So the smaller than, greater than, it changes with the system. I think in Excel, it's probably the same as in Excel. In Excel, it's probably this different too, but sometimes it's the exclamation mark equal. Sometimes it accepts both. So it might as well accept both notations. Well, if one doesn't work, you just try the other, or you look at the documentation to know which one is the correct one. Okay. And this is where the headaches actually start. Because if you try these comparisons and there are some null values in the columns that you use, then this is the cases where you're going to start getting unknown as a result, right? So this is all going to return unknown. You have a null value. That makes sense, right? If it's null, you don't know. And you have a way to try to avoid this. If you want to build more complex formulas, you can test for nullity. You can test, is this value null with is null and is not null. So the mistake that some people do is they write equals null. That doesn't work. Do not say equals null because that's going to say unknown. Say is null. Is null is really testing for yes or no, is that a null value in there. So you should use is null and is not null. Okay. All right. Do not use equals null. It's probably not the intention of what you want. Okay. And then you also have is not distinct from and is distinct from. It's basically the same as equal and different, except that unlike equals and different, this will not give you unknown. So this is, again, a safer way to compare if you don't want to receive unknown. Okay. Then I told you addition, subtraction, multiplication, division, modulo is the percent sign. So that again depends on the language, but in SQL is the percent sign. And you also have the exponentiation, that's the power. So 10 to the power of 3, that's this little caret symbol, right? 10 caret 3 is 10 to the power of 3. If you're a geek, which I am, there's also funny formulas that you can use. It turns out they have a symbol for the square root and the cubic root. You don't need to know them by heart, but again, you're going to have documentation on exam day. But the vertical bar slash is the square root, the double vertical bar slash is the cubic root. The exclamation mark, you know, that's the factorial. 1 times 2 times 3 times 4 times 5 all the way to n, that's factorial n. They have a single exclamation mark if it's a postfix, meaning that it's n exclamation mark. You have the double exclamation mark if it's a prefix, meaning that it's exclamation mark n. You have at for the absolute value. I have no idea who came up with these, right? But this is basically just what it is. The only way to know is to look at the documentation. Okay. And then that's really for the most geeky of us. You even have these very, very advanced things on bitwise operations, on the values, shifting, and so on. You don't need to worry about this. This is really for computer scientists that you start looking into these things. So forget about them. You won't need these things. You also have trigonometric function, cosine, sine, and so on and so on. Can be useful, you know, that even at CERN, we gather data, and this is actually very useful for data coming from quantum physics or particle physics. Okay, so this is also there, available. All right, so that was just a restaurant menu for your predicate. All of that you can cook, do your own cooking and create your predicates that you put in the where clause. Now, if we have this select from where, if I summarize everything we've seen so far, the query plan basically is going to look like from that gets a table, then you have sigma that is going to select some specific rows, followed by pi that is just picking the columns you're interested in, and followed by row that is going to rename the columns to what you want if you use the as keywords. For whom is that clear? All right, so this is the query plan that you will not see as a user. This is totally invisible to you, but whenever you put a query in your Jupyter notebook that says select from where, this is what PostgreSQL is going to come up with in the background. That's called the query plan. Okay, and that then you can start drawing diagrams like this that are called expression trees. This is taught in theoretical computer science when you actually build the SQL parsers that read and interpret your SQL query. Now, regarding the exam, or generally the sort of skills that you need when you learn about querying relational data, you need to understand that there are 4 possible representations of the same thing. And you need to be able to move back and forth between them. The one we are learning right now is SQL on the bottom right. This is what we are learning. The relational algebra, this is what we did last week and finished today. This is with the Greek letters. Then there's, of course, English. That's just the, or that would be the ChatGPT, now we could call it, way of formulating the query. And then you have the query plan. That's what PostgreSQL is doing in the background. These 4 are kind of equivalent. You can transform them in between. I can typically on exam day, for example, we give you an English formulation and we ask you to write the SQL. By the way, if you train for the exam, ChatGPT can do it. We literally put the exam questions in ChatGPT together with the database schema and gave the English formulation, and ChatGPT not only gives the SQL query, but it gives you a full page of explanation of the details of how it's actually building the SQL query. So really try it out. It's really, it can make mistakes, so you need to be careful and critical thinking. But in order to learn, that actually is something that can be useful. I think, for example, if you want to try these things, it turns out that we have a chatbot for the big data lecture called Ethel, E-T-H-E-L. ETH is a bit communicating on that. And there's chatbots that for some lectures that can do it. It might be, I haven't actually tested it, that it might be that the big data chatbot could transfer the English to the SQL. That would actually be worth trying. All right. Okay. And so you need to basically understand all of these different formulations. The query plan, not so much, that we don't insist on, but at least the English, the relational algebra in SQL, you need to understand how they map to each other. Okay? Who is with me? Okay, very good. So let's go back to SQL then and continue to introduce more and more features, what you can do with it. Let's do some sorting. If you sort some data. Again, that's something very practically useful. So of course, if we sort, the order matters. So we are then in the list of records semantics, right? Because the order matters. In fact, PostgreSQL also supports the list semantics. It's able to order the tuples in a specific way. The idea is basically that unless you explicitly ask for an order, PostgreSQL is going to be in bags semantics, bags of tuples. But the moment you ask it to sort, it's switching over to list semantics. That's the idea. So in order to achieve that, you need an order by clause. So you have select from where and order by. So here I'm not including where. You could have where also, but I just don't have any where. So select from order by is going to just reorder the rows, reorder the records, but like this, by ascending birth date. So you see first Spock that was born in 2230, then James Kirk 2230, and Beverly Crusher in 2324. Okay? So this is just a reorder of the records. You have control over ascending, descending. For example, if you say ask, like ascending, then that's going to be in ascending order. And desk for descending, it's just doing the other way around. If you use the spreadsheets, that should be natural to you, right? When you create a filter table in Excel and you click on a column, you can click on ascending or descending. There's two buttons. That's exactly the same as ask and desk here, just written in SQL. Okay. Now, the problem is we could have nulls. What do we do with the nulls? Where do we put them? Well, you decide. So for example, you could say, okay, if there's any nulls in there, just put them first. So you have all the nulls, and then you'll have all other values by ascending order. So nulls first, that's going to do this, right? So you see Spock comes first, doesn't have any last name. Nulls last, just puts them at the end. Right? So this is all things that you can control with the language. So the default values, if you don't say anything, if you just say order by without specifying anything, is going to be ask nulls last. It's basically sorting in increasing order, and it's just putting all the nulls at the end. If you specify ask, then it's just doing it, but that would be the default. It's unnecessary, but you can still do it, nulls last. If you say desk, desk is actually going to put the nulls first. It means by default, it considers the null to be the highest, right? This is what it means. So desk would put the nulls first. And of course, you can also explicitly say desk nulls last if you really want to have the nulls at the very end of your output. Okay? So you can control all of that, ascending, descending, and where to put the nulls. You can also come up with formulas. When you say order by, you can use the restaurant menu I gave you earlier with plus, multiply, blah, blah, blah. So you can build a very complex formula. For example, this double vertical bar in SQL is actually concatenating strings. It's just building a string that concatenates the first and last name. So that's what I put on the left. It's totally useless. That was just an example that I give. So basically, what you order by here is not a specific column. It's a made-up computed value for every record that I put here. And then it's basically sorting based on whatever is here. Okay. It's not used very often. I mean, typically, most often, I think most people just put the name of the column in order by. But if you want to put a formula, you can.
The concatenation of a string and null will always give a null, not the string.
That is a good question. We could try. Can you do it maybe in real time? Check to just try to see what happens if we concatenate a string with a null. So basically, from a design perspective, there's no right and wrong answer. So the only answer is look in the documentation. So it might be PostgreSQL does it in one way. Maybe another system is going to do it differently. So this is really the sort of things that can vary between systems. But still, it's interesting. We can try it and see what's going to happen. So I'll imagine that you will interrupt us as soon as you have an answer, Xiaocheng. All right. Now, here's one more clause. So now we have select from where, order by. Let me add limit. Limit is yet another clause. As its name indicates, it's going to limit the number of records that are shown to you. Limit to is just going to show you the first two records of the input. It should always be done after an order by limit. So if you say order by birth date, limit to, it's going to give you the two lowest values, because that's going to be an ascending order. So the two lowest values. So limit to gives you this, just the first two. Very useful. It's a very good habit to have when you use Jupyter notebooks. If you have very large tables, try to have the habit of adding a limit to your query. That is the sort of things that makes it more efficient. So it can be limit 2, limit 10, limit 20, you know, whatever small number. It's always a very good idea to have control of not outputting huge results, right? Okay, limit 2. it has a little sibling called offsets. Offset 1 basically means it's not just the smallest two, but you skip over the first one and then return the next two. That's what it does. In fact, limit and offset together are called pagination. It paginates the results. In order to understand this, think of a search engine like Google or Bing or DuckDuckGo. What happens when you do a research? It's not throwing at you a million results. It's only throwing at you the first 10. In fact, that's a limit 10 internally. If you say limit 10, it just returns the first 10. In order to get the second page, when somebody clicks next and wants to see the second page, which nobody ever does now, right? But imagine you would click and want to see the second page. That would still be a limit 10 because it's the next 10, but now offset 10. So the second page is limit 10 offset 10. The third page is limit 10 offset 20, exactly. Then limit 10 offset 30, and so on. So this is why it's called pagination. This is the way to paginate the results. Another place that it's very useful is for a web shop. If you have a web shop and people search for products, like Digitech, you can do it, does exactly that. That's going to be using a limit and offset to paginate, right? So the first time you search is going to be just a limit. And when the visitor clicks on next to see the next page, then it's going to add an offset and increase the offset every time. For who is that here? Right? Pagination. Very, very useful, especially when used with a website to display to users. Okay. Now, by default, if you don't put limit and offset, the default values are limit all, offset 0. So limit all basically just says there's no limit, just displays everything, which again, be careful with Jupyter Notebook if it's a huge table. Offset 0 just means there's no offset. So it starts with the first one and displays everything. Okay. This here is a bit dangerous. What I mean with dangerous is that it might not be deterministic. If you say, I want to skip the first 3 and then give me the next 2, technically what it's actually going to do is to throw 2 random records at you. It's picking 2 random records and showing them to you. The reason is that there's no order by. So if there's no order by, you're still in bag semantics. So PostgreSQL can do whatever it wants, right? If you're not specifying an order. So in fact, if I were PostgreSQL and I received that query, I wouldn't even bother with the offset. I'd just throw any 2 at you, maybe the first 2, and that's good. And it's correct because there's no order by. You have no requirement on the order. Right? So this is why be a bit careful with that. It's useful if all you want is to not show the whole table to not explode your Jupyter Notebook, then that's fine. You can just put a limit 10 without an order by. That's totally fine. But do not expect it to be deterministic. If you click again and click again, you might get default results every time. So that can be confusing. Right? So I just wanted to give you that warning that having an order by is a good idea if you use limit and offset. Okay. Let's look at everything we've seen so far. Select from where order by, limit, offset. These are these 6 clauses. Now I have good news for you. The order of the clauses has to be this order. You cannot put them in any other order. It has to be exactly select from where order by, limit, offset. So it means you just need to learn that by heart. There's a few more clauses that I will show you, but you really need to learn that order. They are optional, meaning that you don't need all of them. You can have some of them, but they have to be in the order that is indicated here. Okay, so again, that you need to know by heart. Select from where order by, limit, offset. Looking at the time, we just have a few more minutes. Are there any questions? No questions on Zoom?
No.
Okay. I think I should stop here because aggregation is already, that's the group by clause. It's already complex. Let me see if I still can check the speed. I would like to be sure. Just give me 1 minute. Today is what date? The 15th, right? No, the 22nd. No, the 15th, sorry, I'm completely lost in the dates. Okay. So. There you go. I will share my screen. So you see it on Zoom too. I just want to control that the speed is right. If I'm too slow, if I'm too fast, if I need to explain more, or if on the contrary, you're bored and you want me to accelerate. So just as a check. So I'm not too fast. At least most of you on the okay, so no, the speed is about right then. All right, so this makes sense. So what I see here is basically your different backgrounds, right? Some of them might have a more technical background or already heard about SQL. And so for you, it's easier. And some of you might never have heard of SQL, or it's on you, or you have a less of a technical background. So it's a bit more challenging. So this is expected because this is a service lecture, right? So I have people from all over ETH. So what I see here is that the speed is about right. So now, what I would encourage you to do if you are in the bucket between 50 and 79%, take the exam docker, open the Jupyter notebook, and practice. Write all the queries you can, play around. This is really the best way to learn all of these things and get the intuition. And ask questions. There's the Moodle forum. You can also directly send an email to the TAs. To me, do not hesitate to ask questions. If, however, you understand everything and it's almost boring to you, open the PostgreSQL documentation and read it. That's very instructive, so that can push you a little bit, like explore a little bit further the limits of PostgreSQL and learn the tinier details of what there is in there. Every week, of course, you have reading, so you should read the chapters of the book that I'm giving to you. It's really a good book, yeah, that's pretty much it. So thank you very much for being here today. Next week we'll look into the group buys and halving clauses, and until then, I wish you a good meal and enjoy the exercise session. And please do the practical exercises. This is really the best way to learn these things. Thank you and goodbye. Have a nice weekend.